percentages. And then the second case was repetition. In other words, right, when you don't have any percentages present, then you just automatically default to this case. And you need to, especially when it comes to this one, you need to do a unit analysis, right? We talked about that briefly. And percentages, you have to check if either one of them adds up to 100%. Or maybe there's just one percentage there. If it adds up to 100%, you know you're going to have to end up dividing, because that's our third step. You're going to have to divide by 100 in that case. Let's go to 47. I want you to try 47 right off the bat. There's a chance that some of you may have done this already. If you already done, if you completed this one, just keep going on page 48 or 49, like those questions, if you want to continue reviewing. But I would like you to try this one. Would you be able to figure this question out? You should recognize that it is weighted mean. And you should be able to do the 3 steps, right? The 3 steps, which is multiply, add, and then divide and get the right answer, okay? So I'm going to give you a little bit of time to review your notes, perhaps. Maybe you have to figure out, what was unit analysis again? Like, what is that? It's where you figure out basically what you need to divide your sum by to come up with the right units, right? So go ahead and do that. And if you're done 47, keep going 48 or 49. Those are both, like, I just added more than what I probably needed, just to make sure you have enough. Okay, and then I'll do it with you in a bit. We'll also have to do backwards. Oh, it's 48 backwards. Sorry, hold on. This is a backwards example. Maybe hold. I will go over that in a bit. That's when you're missing one of the entries. So go 49 and on. 49 and on you should be able to do if you're done 47. Okay. All right. I'll be back. I'll walk you through this one. Page 47. So step 1. Well, I guess step 0, at the very beginning, you're like, there are no percentages here, right? So this is the repetition example. Why is it a repetition? Because if you were to collect this data, you would collect from 125 people, they say they paid $12, right? So you'd have 125 12s in your data set, right? That's why it's repetition. So this is telling you how many of these ones you have. But anyhow, we multiply this across. So your weighted mean would be 12 times 125, 15 times 241, 25 times 543, and I would strongly encourage you to do this. That's why I give you marks. If I see that it's just, you just copying the wrong value, that is different than you completely getting it wrong and me not knowing what went wrong, right? So that would be step 1 and 2 right here. Then you need to divide by one of these rows, okay? So you do your unit analysis. So you multiply price times attendance the whole time, or people, right? And what is it that they want you to figure out? The average price per ticket. They want the average price, the mean price. So you're going to have to divide by the people or the attendance, right? To cancel out and be left with this, right? Because that's what they want. So we add up all of these values here, okay? And I kind of butchered it here. Let me just redo this arrow, okay? But if you add up this row here, you get, where's my key? 1237. 1237 is the total number of attendance, right? So this is 1237 down here. And so weighted mean, if you do this all in one shot, I would not recommend that. I'm just gonna, my key has it like that, but I would say, okay, these two multiply give you 1500. And you have 3615. 6075. 5,904 over 1237. One last row, everything on top should add up to 24,594 divided by 1237, and that gives you an average ticket price of 1988 per ticket. If you have the dollar sign in front of it, I would be fine with that. Okay, so that's how you do weighted mean example that involves repetition. Right? So this is your unit analysis, right? You're kind of seeing, okay, what needs to happen here for me to actually end up with the unit that they're asking me for. Okay, and it would, if you divided this by the price, like if you added up this row and you plug it in, your answer would have probably not made sense. Okay, let me just quickly see here. This would be 27 plus 25 plus 18, right? So let's say you added up the top row and you get 70. So now you go 24,594 divided by 70. It would be an average ticket price of 351, which doesn't make sense. Like the highest ticket price is like 18 bucks, or sorry, 25 bucks, right? So the 381 wouldn't have made sense. So that's another way of checking whether or not you're doing things right. Okay. Okay. Did you do? Let's do one more. I want to go to 46, question 8. This one right here, no table. Can you do something like this? Right? So we're in statistics, right? We're in this unit. And so what would you do here? Imagine a table, right? If you don't see it, imagine it. Would you be able to answer this question, right? So go ahead and do that before I move on to some backwards examples. This one I will do just on the background. You guys should share that joke so we can all laugh. All right. 2.12 sports per student. You can't see that because I covered it up here. Right, so multiply students and sport, right, just like that. I do my unit analysis because I've been multiplying these two all along. I want to know how many sports on average. So I need to divide by the number of students. I go ahead and add this column up here to give me the 137. Just do some basic arithmetic and boom, there you get your answer. 2.12 sports per student. And so this would be helpful to compare to another school perhaps. Normally you would just go 2, but the mean is something that we use to compare most likely, okay? So just keep it at that. Or maybe you want to put put some incentives down to bring this up. Maybe you want students to be more involved, right, in sports. So you could then next year look at the data and say, hey, we're at 2.3 sports per student, right? So it means more students are signing up for it. All right, let's go back a little bit. Okay, I'm going even further back. I had said wait with this one for now. Okay, so go to 42. Weighted mean backwards. And you can be guaranteed that there'll be one like this on the test. Okay. So we did backwards with just regular average, but now it's weighted mean backwards, right? So no longer will we wait. We're not going for it, okay? So Addie wrote 3 math tests. That's probably important, right? 3 math tests. Each worth is 20%, okay, of the final grade. He got marks of 75, 80, and 86%. What mark must he get on the final exam, right, which is worth 40%? On the exam, which is worth 40%. This is on page 42, if you're wondering. If he wants a final grade of 86%, right? This is the overall average. That's what the question is saying, right? If you want a mean, right, this is basically mean given. Okay? If you want that 86% average, how are you going to make that work? This is basically what you're going to ask yourself pretty soon after the last test. You're going to be almost in this position. You're like, what do I have to get on that final to give me the mark I want overall? So here it is. You go with the 86%. I keep everything as a percentage. I just leave it like that. Okay, 86% is equal to, each one of these tests you wrote is worth 20%. Okay, so the 75 gets multiplied by 20. The 80% test also gets multiplied by 20. The 86% test is also worth 20 because we're told every single test is worth 20% of the final grade. So now here's the kicker. What must you score on that final exam if it is worth 40%? Okay, so that's how you set it up. This is your final mark here. This is the final exam placeholder right there. Okay. And what do you notice? These are percentages. Both of them are percentages. But look at the 20 and 20. That's 60 already, right? Plus the 40, that is your 100%. And you know what? If it comes down to your final average score in that course, it's always going to be divided by 100, guaranteed. Okay. That's all I'm going to say here for the setup. So this is your initial setup. So now you need to clean this up a bit. You can't just clean it up exactly the same as the other one. There's going to be that extra step. So let's go ahead and find out what these numbers are. So 75 times 20, that's 1,500, plus 80 times 20, 1,600, 86 times 20, 1,720. That's why I leave you lots of space. This one, at this point, I like to just say 40x. Like x times 40 is the same thing as 40x. That's kind of like conventionally how we write that when you have a number and a variable multiplying. You divide this whole thing by 100, right? Just to keep in line with our initial setup. Keep cleaning this up. You go 86 is equal to, we're going to add these values to just get one number out of it. So 1720 plus 1600 plus 1500, that's 4820 plus 40x divided by 100. And here is when you can start doing things to both sides, okay? Once you get it cleaned up, once you've exhausted all of your options, right, you multiplied it all, right? We added the numbers that we could. And once you are at this point, you can start doing things to both sides. This is where I'm going to start using a red pen to show the inverse operations, okay? So the first thing you should always get rid of is if there's something dividing, get rid of it. So we're going to go times 100 on this side. And we're going to do the same thing to the other side. We're going to multiply both sides by 100 to keep in line with the equal sign. So that allows us to do this. So 100 times 86 is just 8600. And on this side, all we're left with is 4820 plus 40x. And the next step is subtract by 4820. You don't want to divide everything by 40 because it would affect everything here. So let's just first get rid of this, get rid of this. Okay? And that essentially cancels this out. That's exactly what we want. And on the other side, it's 8600 minus 4820. That's 3780. Okay? So you're left with 3780 on the left side. And on the right side, you're left with this. And normally, up until this point, you were done, right? With a regular mean, this is it. But you need to do this extra step here. Get rid of that 40. 40 is multiplying x. So we're going to divide both sides by 40. Okay, that cancels out here. Perfect. That's actually a 1. 40 divided by 40 is just 1. And then 3780 divided by 40 is 94.5. So you're left with x on this side, and on this side it's 94. And because we kept everything as a percentage, that is your final answer. Okay. Is it possible? It's still possible. Is it probable? 75, 80, 86. It's pushing it definitely, right? Since the score required is less than 100, it is possible. It is possible to achieve his goal of 86%. You would need a 94.5 to get that 86, right? So there you go. So that's a backwards example. And notice that, right, your initial setup looks a little different than before, because before that final drive or the final test or whatever didn't have a weight attached to it. Now it does. So that's difference number one. And then everything else, though, at first is the same, except for this last step here. Whatever is multiplying, look at my pinky up here, it pays off to have big hands, right? That, right, this multiplication here is also the difference on the last step where you have to divide both sides by 40. Your final exam is worth 20%. So you would have something, 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 right? And then 20% times x, right, for you guys. So keep that in mind. So how about this? If you see x times 20, you know for a fact that your very last step will be divided by 20, right? Whatever is multiplying x, that's your last step here. See a pattern there. Give this a try right away. I have one made for you right on page 43. Give that a try. Completely different weights. The exam is worth 50%. I've had courses in university in math where the final was worth 60%. So I probably told you this already. I'm repeating myself a little bit, but you know, so if she wants a score of an average of 65, only needs to score 44% on the final, right? So it's not bad at all. And then I have a B part. She wants a 95 on the final, so it's just minor changes to copy paste, right? And insert the new information. You can still, the 4300 still stays the same. The final is still worth 50%, right? So really, the only change you're making is insert a 95 here, right? And then just go ahead and do the same thing. So you had tons of practice with this. Right, you have that. Subtract 4300 again. Cancel that out. You're left with 50x. And on the other side, 5200. Divide both sides by 50. Cancel that out. Right, and now that's 104. Needs 104% on the final to get that, which means, right, it's impossible, right? Given that she needs to score above 100% on the final exam, it is impossible to achieve the goal. The goal of 95% average. And if you want your overall average to be 95, it's impossible. So you could probably aim for 90, something in that, or just maybe 92 will work, but not 95%. It's impossible. And I didn't explain what this one was telling us, but it really tells you that she can fail the final, right? She can go get below 50 and still get that goal she wants. Right? So I don't know about you, but I used to do that all the time on the final. I'm like, what are the scenarios here? If I want this, what do I need there, right? If I want this. So basically what we're doing here, if you can apply that, and after the final test, you can start doing that, right? I'll show you how to do that one more time when we get there. It's actually a bit simpler than what we did today. Okay? All right. There's one more backwards that is not involving final marks. So let's keep going here. This one, I want you to try that. The idea is the same. This is on page 48. 48. The idea is the same. I only have one example in here. Not very common. Usually it has to do with your final grade. Okay? But in case I do put that on there, you should be prepared for it. You don't have to worry about this on the quiz, but maybe on the test, right? I'm not quite done making your tests yet. So apply the same reasoning, right, with weighted mean in this scenario, but you need to figure out what is the number of boxes here to get that average. So 1 second here. Did I get this right? Sorry, I never tell you. So this is not backwards, sorry. This is not backwards, but there's a twist to it. So this is not true backwards. How is that? There's enough information here to let you figure out the x. There's enough information. If you read the question, you have enough information to figure out the x. But it's not the full-on backwards. You're told how many boxes there are in total. You know all of them except for one. And I just want you to find the average weight per box, really. But the added twist to figure out x first. But you know how many boxes there are. This should add up to 75, right? The number of boxes. Okay. So figure out how many boxes you would need here to have a 75 sum. And then figure out the weighted mean, which is the average weight per box. So it just added a little twist. I'm going to highlight this part. There are 75 boxes there. So this should add up to 75 here. And this box right here, if you had one, should add up to 75. So figure out x first. It's a mini backwards question. How's that? So try that, and then after that, so I'm quickly going to figure this out here. Mini backwards, right? Mini backwards. So 75. So 20 plus x plus 16 plus 25, right? If you were to add these up, you should be getting 75, right? So when you have that, just add up the values on the other side. It's frozen. Let it go. Let it go, right? 20, 16, 25. This is 36, right? 36 and 5 is 41, so 61 plus x, right? Take away 61 from both sides, and you get 14 boxes. Is that right? Yeah, 14. 14 boxes. So we know now that this is supposed to be 14, no longer x, right? So that was just like a mini backwards scenario. Now you have everything you need to figure out the weighted mean. So I'm just going to multiply like this and add those up, okay? And I'm going to speed through this a little bit. You just check to make sure you get this right. here's the kicker. What do I divide by? Right? What do I divide by? I'm just going to go pounds times boxes. That's what I've been multiplying all along. And it's asking me to determine the average weight. So you want pounds to be left. So you have to divide by boxes, right? So you can do this. That's basically what you're doing here. So you add up the boxes. We know that's 75. Thank you very much, right? We know that's 75. And here's your grand finale. You get 2880 over 75. And that's 38.4 pounds per box on average. If you had divided this by the weight, the combined weight, you would have actually found the boxes per pound, right? So it's slightly different. I'm going to stop this here. This is